1 second. Okay. F of x equals 5x squared times x minus 2 times x minus 5. Good. What is our leading term? We're going to multiply the 5x squared times x, right? Because these are not raised to any exponent. So we get 5x to the 4th as our leading term, right? When you look at (5x to the 4th), that's a positive x to an even exponent. So it's going to be going up on the left and going up on the right. Good. How many turning points? X to the 4th power, that means it's going to be less than or equal to 3 turning points. So it might look just like that. Good. So those are our turning points. That's our end behavior. Now, real zeros. I'm going to do a better job this time. Real zeros means you're just looking at your x's, you're not looking at your constants. Okay? So we have 5x squared, x plus 2, and x minus 5, right? And we can just set those equal to 0 without their exponents, so don't worry about the exponents. 5x is 0, x plus 2 is 0, and x minus 5 is 0 to find your r, because x minus r is where your r's are, your real zeros are when you're factoring. There's nothing you're subtracting from 5x, right? 5x minus 0. So my r is 0. Or divide by 5 and still get x is 0. Good. X plus 2, subtract that 2. X is negative 2. X minus 5. Oh, sorry, add 5. I already wrote that. Plus 5. X is 5. So those are your real zeros. I know I write them as x's because I'm solving for x, but it's for your real 0, 0. Your real 0 is a negative 2, and your real 0 is a positive 5. What are my multiplicities of those? My multiplicity of this one, you go back and you look at that exponent, my multiplicity is 2. There is no multiplicity, so we're just going to say it's a 1. It's an understood 1. There is no exponent or no multiplicity, so it's an understood 1. Good. So let me write these points correctly this time. This is the point 0, 0, and it's even multiplicity, so it's going to touch. All right. Here is the point negative 2, 0. It's going to cross because 1 is an odd number, so every odd multiplicity is going to cross the x-axis. This is the point 5, 0. And it is also going to cross because it is also an odd multiplicity. So if I was going to put these in order, I'm going to be crossing at a negative 2, 0. At 0, 0, I'm just going to touch. And then I'm going to be crossing again at 5, 0. And I know I'm opening up. So I guess it'll be more like this. Good. So those are my real zeros. My y-intercept, if you already found it as one of your zeros, your y-intercept is just 0, 0. And you'll know that because of what happened when you found your real zeros. So that's what I should have told you for 2a. If you already found your y-intercept, don't worry about your constants. They will disappear. They will be multiplied by 0. All right, let's try to graph this. We know it's going to start, it's going to open up to the left and to the right. It's only going to turn 3 times. It's going to cross 2, 0, 0, 0, and 5, 0. And again, after you graph these, you want to put them into Desmos just to be sure. So here's -2, 0. Here's 0, 0. And here's 5, 0. We said we are touching, we said we are touching 0, 0. We are crossing at -2, 0. And we are crossing at 5, 0. We don't really know how far down they go, but we know where they touch and where they cross and that they open up. Good. All right, I think this is our last one. The third example is f of x equals -2 times x minus 1 squared times x squared minus 16. All right, our leading term. We want to multiply the -2 times this x squared times this x squared. Good. -2 times x squared is just a -2x to the 4th, right? When we look at this, we have a -x with an even exponent, so it's going to be opening down to the left and to the right. So that's like end behavior. My number of turning points is going to be 1 less than the greatest degree of this leading term. So it's less than or equal to 3 turning points. Good. Then I'm going to find my real zeros. I have x minus 1 squared. I have -2. And I have x squared minus 16. Not raised to any power. Good. Okay. The -2, there is no x, right? Oh, hold on. Sorry, guys. A moment. All right. The -2 doesn't even have a 0, or sorry, doesn't even have an x. So there is no x is, there is no real 0 being subtracted from x because there's no x, right? So we don't even need to worry about it if it doesn't have an x, okay? You can just ignore it. X minus 1, that's pretty straightforward, right? X minus r is your real 0. X minus 1, set it equal to 0. X is a positive 1, so my r here is a positive 1. It's raised to the 2nd power, so it's a multiplicity of 2. Is that okay? All right, just like usual, right? So that point is, before I mess it up, that point is 1, 0, and it's going to touch there. I need to finish that so that I don't look back too quickly and mess it up. All right, I want you to think about x squared minus 16. What you can do is you can set it equal to 0 if you want. Just like we set that one equal to 0 and we found that r was 1. X squared minus 16 is 0. It's just going to look a little bit different, okay? We'll add the 16 to both sides. You get x squared is a positive 16. Good. Then we're going to take the square root, right? Because we're trying to find x. The square root of x squared is x. And then remember, if you employ the square root to solve for an x squared problem, you put plus or minus in front of it. So plus or minus the square root of 16. We know that the square root of 16 is 4. So x is a -4 and x is a +4. So you have two r's here. You have r is -4 and you have r is 4. In those situations, this x squared got us the two different answers. This is not the multiplicity. The multiplicity is of the entire factor itself, and that's a multiplicity of 1, okay? Multiplicity of 1. So at the point -4, 0, it's going to cross. And at the point 4, 0, it's going to cross. Good? Okay. You can also look at this as the difference of two perfect squares, right? And we know that anytime you have a perfect square as your A and a perfect square as your B, and B is being subtracted from A, you can just change it to x plus 4, x minus 4, right? And then we get the same answer in the end for our r's, and they're both still raised to only the first power. So you can do it this way, or you can do it like this. Either way, you're going to end up with your real zeros are -4 and 4. Good. So we know our leading term, we know our y-intercepts, or sorry, we know our x-intercepts, we know our leading term so that we know what the graph is doing, how many times it's going to turn, and then, sorry, I said our y-intercept. The y-intercept, can we still see it? No, I'll rewrite it. F of x equals -2 times x minus 1 squared times x squared minus 16. Good. So for our leading term, we multiplied the -2, the x squared, and the x squared, right? For our y-intercept, we're going to multiply the -2, the -1, and the -16. The -1 is squared. So we're going to multiply -2 times -1 squared times -16. Ready? -2 times -1 squared times -16, because those were our constants of our three factors. Good. When I multiply that, that just becomes -1 squared becomes a +1 times a -2. The -2 remains a -2, but -2 times a -16 becomes a positive. So it's a +32, which is the 0.032. Good. And if you had wanted to, you can just change this to -2, like we did right here. X minus 1 squared. And then you immediately change this to x plus 4. Sorry, x minus 4, because you know that x squared minus 16 is the same as x plus 4 times x minus 4. Then your y-intercepts would be -2, -1 squared, -4, and +4. But those two would still multiply to 16. So you would still get the same answer. Okay. So when you have the difference of two squares, you are welcome to factor them out. If it makes it easier to find the real zeros, easier to find the y-intercept, you will still get the correct answer. Good. All right, this is kind of a big one, -4. So at -4, we're going to cross. At 4, we're going to cross. At 1, 0, we're going to touch. And then it's going to cross the y-axis at +32. So we'll just say that that's right here. Good. All right. And then just, we know it opens down on both sides. touches there, goes back down. Good. All right. So there are 3 turning points. Yes, there are 3 turning points. It crosses in all the right places. And you are welcome to go over to Desmos and make sure that your graph looks like the graph in Desmos. Let me stop.